The James Webb Space Telescope, jUST, has spotted hints of activity way out there that could be from someone else, bringing us closer to answering that old. People have always wondered about life on other planets. It's inspired books, movies, and countless theories. We seem to have this need to know if we're the only ones around, and that drives us to look for company even if it's not from Earth. Back in 2021, some people wondered if our future telescopes would be able to see things like city lights on a planet, such as Proxima b. This planet is the closest one to us outside our solar system. It's in the Goldilocks zone of its star, Proxima Centauri, which is about 4.25 light-years away. Some thought Proxima b might be tidally locked, with one side always facing its star, much like our moon. If that were the case, maybe intelligent beings could move heat and power from the sunny side to the dark side using solar panels. A paper by Manusvi Lingam and others suggested that if Proxima b had many solar panels on its sunny side, future telescopes could detect them. Now, in 2024, the jUST is sensitive enough that it might help us look for artificial light or signs that planets like Proxima b could support life. This could push us forward in a big way. Before we get too excited, it's important to understand how we can do this. The James Webb Space Telescope is still observing Proxima Centauri b because it's such an intriguing place to study. People have always searched for answers to big questions about the universe, our place in it, and what's going to happen to us. We've been curious ever since we could think. With technology moving so fast, a philosopher might say we're just beginning to understand things, while astronomers are thrilled to share their latest discoveries. The public might not always notice these advances, but they're monumental for us as a species. As we explore, with the world basically at our fingertips, we're set to study space like never before. One of the main ways we're doing this is with tools like the jUST. This telescope builds on decades of space exploration and is designed to answer fundamental about where we fit in the universe. It's already giving us clues about possible life beyond our solar system, for example. It may have found artificial light on a distant planet called Proxima b. Proxima b, or Proxima Centauri b, is an Earth-like planet that orbits a type of star known as an M-type, or red dwarf, star. These planets are usually larger than Earth, but smaller than ice giants like Neptune, making them quite unique. There's still a lot we don't know about Proxima b, but this discovery marks a huge step forward in understanding our place in space. The first possible evidence of planets outside our solar system appeared as early as 1970, but few paid attention then. It wasn't until 1992 that astronomers confirmed one, a discovery that amazed scientists and sparked an ongoing search. Since then, we've found many more, including a notable one in 2003. As of April 1st, 2024, we've confirmed 5,653 exoplanets in 4,161 systems, and 196 of those systems contain more than one planet. Most of these discoveries are around M-type stars, also called red dwarfs. Red dwarfs are small, cool stars that are far more common in the Milky Way than other types. Because of their low brightness, they present unique challenges for observation. These stars typically have surface temperatures of about 3,900 Kelvin. Proxima b is thought to be about 1.07 times the size of Earth. It orbits its star in just 11.2 Earth days, compared to our 365.25-day year. This shows how small its host star, Proxima Centauri, really is. The star emits only about 0.16% of the sun's brightness, an invisible light. It's even dimmer, around 0.056%. Most of its radiation is in the infrared. Proxima b orbits roughly 0.04856 astronomical units, AU, from its star. The discovery of Proxima b, announced in 2016, immediately sparked curiosity. One major reason is that Proxima b is the closest known exoplanet to our Sun, just 4.2 light-years away. It's part of the Alpha Centauri system, a triple-star system. Perhaps the most fascinating question about Proxima b is whether it could harbor life. It lies within the habitable zone of its star, which keeps astronomers deeply interested. That's where the jUST comes in. The telescope's scientific goals include searching for light from the first stars and galaxies that formed after the Big Bang, studying how galaxies evolve, understanding how stars and planets form, and exploring planetary systems to learn where life might originate. The search for life beyond Earth, especially intelligent life, is a central focus of modern space exploration. Humanity's drive to understand everything pushes us to look for signals from civilizations we can barely imagine. It's like a cosmic treasure hunt. Instead of gold, we're searching for electromagnetic whispers across the stars. If we ever detect artificial light or other signs of technology on planets like Proxima b, it would be monumental. It would change how we view the universe and ourselves. The idea that we're not alone could transform our beliefs, societies, and even our future on Earth. Discovering intelligent life elsewhere would mark a turning point in human history as groundbreaking as the first moon landing. It would begin a new era in space exploration where Earth is no longer the only home of life. One of the jUST's main missions is to explore the unknown. It's built to see deeper into space and further back in time than any telescope before it. This allows researchers to observe distant stars, galaxies, and planets with incredible precision, helping us better understand the early universe. The James Webb Space Telescope doesn't just look for life, it's helping us understand how life might begin in the first place. By examining the atmospheres of distant worlds, it can detect gases like oxygen, methane, or carbon dioxide, the kinds of chemical signatures that on Earth. When jUST observes a planet as it passes in front of its star, light from that star filters through the planet's atmosphere. This lets scientists break down the light into its spectrum and see what elements or molecules are present. It's like taking a fingerprint of another world. If we ever detect a clear pattern of artificial light or a mix of gases that could only be produced by life, it would be one of the biggest discoveries in human history. Proxima b is a great test case for this kind of search. Because it's so close, even small signals could be easier to spot. Scientists hope that within the next few years, jUST and future telescopes like the Extremely Large Telescope, ELT, and LUVOIR will help confirm whether this mysterious planet has the conditions for life. But finding life isn't the only goal. Every image, every spectrum, and every tiny bit of data jUST sends back helps us understand how stars and planets form, evolve, and sometimes die. It helps us see the cosmic story that led to us being here at all. When we look at worlds like Proxima b, we're also looking back at ourselves. We're asking how rare Earth truly is and whether somewhere out there another civilization might be looking back at us, wondering the same thing. The more we learn, the more we realize how connected everything in the universe is. Our atoms were once part of stars that exploded billions of years ago. The James Webb Space Telescope is humanity's newest eye on the universe. And with each new discovery, it's rewriting what we thought we knew. From faint glimmers of distant galaxies to the possible lights of an alien world, it reminds us that the universe is vast, mysterious, and alive with possibility. Every discovery the James Webb Space Telescope makes brings humanity one step closer to understanding the grand design of the cosmos. Each image it sends from the fiery birthplaces of stars to the cold edges of ancient galaxies is a message from the universe, written in light billions of years old. But perhaps its most important mission isn't just about finding planets or galaxies. It's about perspective. When we look deep into space, we're also looking back in time, back to the origins of everything we are. Every photon captured by jUST has traveled across unimaginable distances, carrying stories from when the universe was young. Proxima b may or may not host life, but its study is helping us learn what's possible. Maybe it's empty